Hello and welcome to another interesting episode of the semiconductor webinar. Today we have Anushka Tripathi. She is an engineer at Mach 9 Tech, where FPGA based SoC design projects are being worked on. Aryavat Semi was founded by her as an initiative to spread semiconductor awareness to build a stronger tech community in India. Her internship was undertaken at DRDO SSPL, during which contributions were made to FPGA based defense application, strengthening hands on expertise in system design. So, folks, let us see today. Anushka has her presentation as well as files and all details to share on the semiconductor webinar. Welcome, Anushka. And from this point onwards, you will be taking over. So, over to you.
So let us build a SoC with open source SoC builder. So first of all, motivation. So it all started when I was working on a SoC project. So it needed a flexible way of. I was exploring a software which can help me integrate CPU peripherals and custom logic. And the challenges faced were vendor tool chain felt restrictive, hard experiment and modify hardware at the SoC level. So why LiteX? So it is open source and modular. It gives freedom to design without limitations. It helps in quick prototyping uh, and helps in testing ideas directly on FPGA. And it is an educational tool. It helps you learn build SoC in a very easy way and impact. So it helped me explore RISC-V and SoC design more practically. It gave me confidence to build and modify hardware systems from scratch, opened a path towards semiconductor innovation and startup projects. So block diagram. So first of all, I decided a platform, then the SoC core and the peripherals. Like you can use any processor you want, a VEX RISC-V or SERV processor, which is mentioned in the description. And I decided the peripherals like LED switches, TFT display. And you can make any peripheral like PWM also, and then translate the SoC description. I created a Python file, uh, described the behavior of the SoC, and created a wrapper and designed the submodules like the display peripheral. And then I generated a bit stream for the FPGA to deploy and use the USB. Then I deployed the bitstream to FPGA, and using LiteX from I deployed the firmware on that and did the successful testing of that. So this is the our uh, display module which we made for the TFT display. So this is the our FSM for the TFT display, or any display you can have, 7 segment or anyone. Next. So if you want to use LiteX, so for this it is important to know that the uh, opens Migen. So it is an alternative HDL based Python. So it allows generating Verilog or instantiating Verilog or VSTL from Python code. So it basically uses Python to create a list of combinational and synchronous assignments and generate a Verilog file from these assignments. And Migen has an integrated SoC simulator that allows test benches to be written in Python. So A module is a block containing a functional description that uses inputs and outputs. So here is our module. Clock, write, button are our inputs and LED is our output here. So interfaces of modules are defined by attributes. So all attributes with the type signal are considered interfaces of the module. So in our case, so right button LEDs are our signals. So core of Migen design model. Everything you describe is either combinational logic, like a wire or continuous assignment in Verilog, synchronous logic, like a register updated on clock edges, and in Migen, each module has two lists to hold these assignments. Self.com are for combinational assignments, self.sync um, for clocked assignments. Assignments are added using this plus is equal to symbol. Then next. So so this is a simple code of. So first we will understand how to describe combinational assignments with the help of Python. So this is our Verilog, and this is our translated Python for that. So so here we create a class, combinational example, and under that we define the object self. So self.a is our signal, and input signal. A and B are our input signal, and out is our output, which we get after ANDing the A and B. So using self.out, we get the output of our combinational circuit. Then we move to a synchronous assignment example. So here we use the self.sync for getting our output um, of our of our statement, which is a plus b is equal to out. So in Verilog assignments, the out gets changed on every positive of edge of the clock, and similarly, this will work in Migen Python module also. Next, using them both together. So here is an example where we have used both combinational uh, and synchronous example together, sequential circuit example together. So here sum is equal to a plus b. Here we have uh, done sum of the signal a and b and assigned to some some signal. And then this is the synchronous assignments. So we have assigned the sum to the out. Uh, Now next, this is our simple example of designing a blinker with Migen. So here we have here we increment the counter and assign the output to the LED. So self.led here, it's drive the LED hardware pin, and it is connected to some external input, and it self.button represent a 5-bit wide button input, And counter, it is an internal 25-bit register used to divide the clock. So here let us understand about the LiteX design flow. First of all, we create our SoC design with the help of Python, and we add our add various IPs like DDR, RAM, PLL, etc. And then HDL is generated, and then when the HDL is generated, it generates some other file like .csv, .json, .h. So .csv helps us with the register map, and .h are our software files, and then we have the vendors. It also generates files like .xtc, .tcl, etc. And then we get the complete bit stream, which we deploy on the FPGA. And LiteX also provide hard and soft CPUs. So it have many CPUs like Pico RV32, SoC processor, VEX RISC-V, and you can also integrate any other CPU also, you because this is an open source tool. Next, it also provide a very big library of various simple codes like DMA, JTAG, LED, PWM. Next, it also includes various other important IPs like PCIe, SPI. So we have not used in our project these things, and it have kept for future exploration. Next, as we when we will go on to understanding our Python code, we will it will be important to know what is CSR. So CSR is just a memory location inside your SoC that the CPU can read or write to in order to control hardware or get information from hardware. Think of it as a switchboard between software and hardware. So suppose you have 8 LEDs on your FPGA board. Hardware makes them accessible through a CSR at some memory address. So if software writes this to that CSR, the lower 4 LEDs turn on. So if software reads that CSR, it gets the current LED states. So this is how we use CSR using LiteX syntax using the Python. So we assign a CSR memory address for LED peripheral using this, and it generates C header and CSR.csv file, so your software knows how to access it and lets the CPU control LEDs just by writing to memory. So now let us move on to uh, our demonstration, our code.
Yes, Anushka, you want to switch over to the codes, right?
Yes,
Okay. So I let me stage it down. Okay. Now from the menu, you can add the respective tab in the same way.
yes. I have done the share screen.
Uh, mm, no, it has not yet staged. So can you try again?
Should I do entire screen?
No, you can just the respective slides and PDF, right? Not share screen. Yes, you will use the share screen. I think that is the option. Share screen. You share the entire screen.
Yes, it's visible.
I think there is a latency. Let me check because your slide is still there.
Should I remove the slide?
Yeah, you remove the slide. Okay. Now you do the screen sharing.
Yes.
I think it has come. Yeah. Let me add it to stage. Yeah. Go ahead.
So this is our base.py file with which we have implemented the SoC. So first of all, we import some important libraries to import the Ultra, some FPGA specific files we have imported, the SoC builder, and we have we have designed a wrapper also for our modules. So this iOS is our so is my iOS.py file visible? Are my other
It is.
files visible?
I think you can switch on the tabs. Is it on other tab or other totally other screen? I think you have shared the screen, right? Yeah.
Yeah,
So the first tab is there. You will go to the next tab and next tab like that. There is no issue.
yeah. This my PWM is visible, right?
Yeah, yeah, it is visible.
Okay. So we import the SoC builder, the cores, and the builder, and from iOS we import. So iOS act as a wrapper. So we import iOS. From that we import the switch class, the RGB LED for our implementation. Then we import the display file. So this is our display design. So this is a FSM we have created, and this is the test bench. And when I run this display.py, this will be our simulation. So here it is sending the 8 bits data, and this is it is sending through the 8080 parallel sending scheme. So uh, this is our test bench, and this is our FSM. So the FSM block diagram I have shown you that earlier, that we have implemented here. And then we this is our Ultra platform which we have defined. This is so it will be specific to your FPGAs. Then we have instantiated our we have defined the CPU type, the clock frequency, and then we have specified the size of our ROM and RAM. Then we have instantiated our CRG module. So it requests it creates the clock signal. Then we have defined our LED module, and then we have implemented the switches. This is our display, and we have instantiated the SoC. So this create the SoC instance which builds the internal structure, and we have created a builder. So it gives the SoC this is the instance to build SoC, and uh, we have specified the output directory, and we have with this we run the build process, and then our files are generated. So this is our generated SoC, and here we have designed our firmware. So we build using the make file, we build our firmware and then we deploy onto the FPGA, and we deployed that this firmware on the FPGA using the LiteX term command. So this was so I'm done with the explanation.
Yeah, I think in anything else to show on the screen.
No,
I think then we can come back to the face layout, and let me remove it from stage. So viewers, today you have seen the technical demonstration of the open source FPGA that Anushka has done at her end, and she has shown all the sub steps one by one with minute technical detail. So I think you have an interesting journey today. Although it is not possible for you to grasp all the thing in very short period because she has spent a whole lot of time behind it. So uh, I think we had some comment from viewers, but not questions. I think Vivek said Vivek Anand said hello. And is he a friend or colleague to you, Anushka?
no,
I think he is then our viewer. Thank you, Vivek, for joining the webinar. And I think Paresh Patel, he has uh, joined the webinar and he said hi. And he is also from your known circle, Anushka.
no.
I think then again an interesting viewer. So thank you, Paresh, for staying with us. And we don't have questions today. I think Anushka will explain all the topics today. And this is an open source FPGA, which is very, very different from the paid thing that we find in Xilinx, right? Or any other paid mode of FPGA. So those who want to try out, we will have some links where Anushka has this repositories. We'll later add those links in the video and in the comment section so that you can go ahead and see the project. And if you want to explore on your own, you have all this, because the beauty of the open source is that you have everything in front of you. Every resources is there. You can try out at your home PC, like desktop or laptop. So you are free enough to move any direction. And Anushka, apart from the technical presentation, anything you have to say to our audience who have patiently watched today's webinar, or maybe in future they will see the recorded version of this, because there we differ from regular webinars, because our webinars stay recorded in our channel, as we respect viewers time, because many people are from many time zone and people might have some busy schedule at this time, so they can later watch on the entire webinar recorded. So anything you have to say to our viewers, Anushka?
So, any technical kind of thing?
Anything you want to encourage the youngsters, the youth, anything?
Um, so you should. So there's very less content on internet to learn about this tool. So we should all work together on this tool to come up with some more. We should find ways, better ways to leverage this tool. As I have shown you, there are many modules in this, like the LiteX PCI, LiteX SPI. So it have a light scope, which is a debugger. So we should work on these things and uh, come up with some blogs like how to use all these things so that everyone will get to know how to use this tool. Yes.
Great initiative. Anushka, you showed another very uh, important side of the open source movement, right? Because any student they want to try out, right? Maybe student, or maybe at college level, anyone wants to try out, they can go for this LiteX platform, which is open source. So, thank you very much for presenting to our audience, and it was a very exciting journey today, because it is one of its kind. Because we have talked about different uh, domains. Today we have covered a domain that was untouched, the FPGA. So thank you very much. And since there is no questions, generally we keep last 10 minutes for the Q&A, technical Q&A. I don't see any questions coming up, because I think this was totally new in the sense, people are not very much used to or familiar with such kind of open source performance, right? So I think people uh, will take time to assimilate all the stuffs that you have presented. So with that note, we will say goodbye to your audience today. Uh, Bye, audience, today, and see you in the next episode. That means the upcoming, whether it is a semiconductor webinar or the semiconductor podcast, will come up with another interesting episode with another interesting personality from our domain. It's our domain, our show. So stay tuned, stay focused, and bye for today.
Yes.